All right, we are going to look at the back side of the 10.3 notes now, the second page of those notes, starting with example 2, where we're going to use this Venn diagram that has some data about high school seniors, and we're going to use that data in the Venn diagram to find some probabilities. And notice these are all conditional probabilities, probability of A given B. So I'm going to remind you of the formula that we had on the front, which said the probability of A given B equals probability of A and B. Remember that symbol of the and, the intersection symbol is the and, divided by the probability of B. Okay, that formula is on the front of our page. We also have that is equal to the total number in A and B divided by the total number of object students, whatever the case may be, in B. So in order to do this, we're going to need some totals. So off to the side over here, I think I'm going to give you, we're going to calculate some totals. So the 21 is car owners that do not have a job. So the 27 is those car owners that do have a job. So the total number of seniors that have a car is 21 plus 27, which is 48. 21 plus 27, which is 48. Now, I do want to look at the overall total because there's something interesting here. 21 plus 27 plus 33 plus 19, that overall total. 21 plus 27 plus 33 plus 19. That overall total is 100. So actually, we could be talking about a survey of 100 high school seniors, or we might have percentages. This 21 could actually be 21% of my high school seniors own cars. And it really doesn't matter whether we look at those as percents or being totals. Our answers will come out the same because these can either one of those can be used to calculate the probability of A given B. So we've got 100 altogether, whether it's a percent or number of seniors, it doesn't matter. Car, so there's 48 there. After school job, the percent that have an after school job is 60. Out of 100, which is 60%. These 19 down here have no car and no job. All right. Remember what we said, the 21 are the number of car owners that do not have a job. 33 is the number that have a job but no car. We've got the overall total, which is 100. We need the total number of students that have no car. Number of students that have no car is 33 plus 19. 33 plus 19 is 52. And we need the total number of students that have no job. Okay, these 19 have no job and these 21 have no job. That's 40. I think we have all the totals that we need. If not, we'll calculate another total if we discover we need it. Okay, so for part A, using the Venn diagram, the probability that we have a student with a job given that they're a car owner, senior with a job given that they're a car owner. So a job given that they're a car owner. So we take the number of students that have a job and they're a car owner, so that's our 27, and divide by the total number of car owners, which we calculated as 48. That's this number right here. So 27 over 48, we will reduce that fraction if possible, and yes, it is possible because 27 and 48 are both divisible by 3. So we'll reduce that fraction to 9 over 16, and instead of using percents, I'm just going to leave them as reduced fractions. So 9/16 is our answer there. Okay, part B, probability of no car given that they have a job. So we're going to take the number of students that have no car and a job, No car and a job, that's our 33. No car and a job. Remember, total in A and B. No car is A, job is B. Total number that have no car and a job, that's 33. And we'll divide by the total that have a job. There's our B. Total with the job is 60. So 33 out of 60. We'll reduce that fraction. Divide out of 3. We get 11 over 20. There's our answer. Okay, I want you to also think about when we do this kind of probability, let's look at this in the next one. Another way of looking at it would be if I want to know the probability that I have a car owner given that they have no job, I'm going to restrict my sample space. I only want to concern myself with those that have no job. So I look for the car owners that have no job, that would be 21, and divide by the total number of seniors who have no job. That's the 40 right there. So 21 over 40, that fraction does not reduce, so that is our answer, 21 over 40. Okay. All right, part D. Probably they have no job given that they have no car. So I find the number of students who have no job and no car, the seniors who have no job and no car. No job and no car, that's the 19 that's down here. No job and no car. And I divide by total number of seniors with no car. In other words, my sample space has been restricted to just focusing on those that have no car, and that is 40. Nope, no car is 52. 52, 33 plus the 19, we calculated it, right? No car is 52. 19 out of 52, that fraction does not reduce, so we are done right there. Okay, part C. Or E, sorry, part E. The student from the sample works at McTaco. What is the probability that the student is a car owner? So what are we looking at? We're told that the student has a job. So I want to know the probability that the student is a car owner given that the student has a job. Probably that they're a car owner given that they have a job. So we take the total number of car owners that have a job. So they have to look at where they overlap. Car owners that have a job, that's 27, and divide by the total number of students that have a job. Remember, here's my A, here's my B. So I find the number that are in A and B, car owners and job. That's the 27. And then we divide by the total in B. In other words, the total that have a job, that's our 60. We will reduce that fraction. We can take out a 3. And we get 9 out of 20. And we are done. So probability of 9 out of 20 is 9 out of 20. All right. Part F. If a student is a student from the sample more likely to have a job if they have a car. Justify your answer using conditional probability. So I'm going to first of all look at, in my sample, probability that a student has a car is 60%. 60, oh, not 60. Probably they have a car is 40. Hold on. Rewind. Is a student from the sample more likely to have a job if they have a car? I need to calculate the probability that they have a job. And then I'm going to compare that to the probability that they have a job, given that they have a car, and also the probability that they have a job, given that they don't have a car. Is a student more likely to have a job if they have a car? If that's the case, we would expect that this probability would be the highest of them all, right? If they're more likely to have a job when they have a car, then the probability of a job given that they have a car should be the highest. So let's calculate those three probabilities and compare them. So the probability that a student has a job is 60 out of my 100 have a job. So that's 60 out of 100, or 60%. Probability that they have a job given that they have a car, we've already calculated that. That was 9 out of 16 or 27 out of 48. Either way, I'm going to grab a calculator and I'm going to work out that. See, that was part A, right? Probability that they have a job given that they have a car. That was 9 out of 16. That's 0.5625. Which, when we change that to a percent, is going to be 56.25%. Like that 6. Let me fix it a little bit. There we go, better. And finally, the third probability that they have a job given that they don't have a car. That's going to be the probability, the number of seniors with a job and no car. Job and no car, that's 33. Number of seniors that have a job and no car, that's our 33 right here. And we're going to divide that by the total number of students that have no car. Well, that was 52, right? Total number of students with no car is 52. Again, I'm going to grab my calculator. I'm going to do 33 divided by 52. And that's going to be 0.6346. That is 63.46%. That decimal goes on, but it rounds to 0.6346. That's 63.46%. So compare the probabilities. It is actually those students who don't have a car that are more likely to have a job. So is this student from our sample more likely to have a job if they have a car? No, they're actually more likely to have a job if they don't have a car. So they're more likely to have a job if they don't have a car, because that probability is higher. Probability of having a job without having a car is actually higher. Okay, more likely to have a job if they don't have a car. All right, let's look at example 3. So in example 3, we have a Venn diagram that we have to fill out. Real estate ad suggests that 68% of homes have a garage or a pool or both. 64% have a garage, 21% have a pool. Fill in the Venn diagram and answer the following questions. So we want the probability that they have a garage and a pool. Remember, this is the and. Probability that they have a garage given that they have a pool. Probability of a pool given that they have a garage, and so on. All right, the first thing I'm going to do is notice that the percent of homes that have a garage or a pool or both is 68. So the sum of these three is going to be 68%. 64% have a garage. So notice if the sum of the three is 68 and 64% have a garage, that means there's 4% over here. Right? Think about that. 21% have a pool altogether. That makes this a 17. Let's go back to that again, just for a second, so that makes sure everybody understands. 68% have a garage or a pool or both. That means these three have to add up to 68%. These two have to add up to 64. That's a 4% difference. That means 4% has to be right there. 68 take away 64 equals 4% there. Okay, now I do know that 21% have a pool. So the missing blank here in the middle, take away the 4. 21 take away 4 will get me that missing blank in the middle. So 17%, because the two numbers here have to add up to 21. So that has to be a 17. Now I know that 68% have a garage, a pool, or both. So I could do 68 take away 21. And get my 47% that needs to go here. Or I could do 64 take away 17 and get 47. Either way. And then finally, 47 plus 17 plus 4. Oh, that's my 68, right? That's my 68. 100 take away 68, because we're talking percentages here. 100% take away 68% gets me that 32% do not have a garage and they do not have a pool. No garage, no pool. All right, so the first thing we had to do was fill out the Venn diagram. We've got that. Make sure you're happy with those numbers and understand where they come from. Now, probability that they have a garage and a pool. Well, that's easy. That's 17%. It's the number right here in the middle. A garage and a pool. A garage given that they have a pool. Okay, garage given that they have a pool. That's going to be 17 divided by 21. Because the number that have a garage and a pool is 17, and then total number that have a pool is 21. And we can change that to a decimal, change it to a percent, whichever we want. If you change that to a percent, so I'm going to look at it as a percent as well. 17 divided by 21, 80.95%. Okay. Probability that they have a pool given that they have a garage, part C. So I look for the number that have a pool and a garage, and I divide by the total number that have a garage, or the probability. Probability that they have a pool and a garage is 17%. Probability that they have a garage is 64%. And if we want a decimal for that, we grab our calculator, we do 17 divided by 64, and we have 26.56%. Okay, next one. Probably that they have a pool given that they have no garage. So I look for the probability that they have a pool and no garage. That's 4%. And I divide by the total number that don't have a garage. That's 36. That's the 4 here plus the 32 here. That's 36. That, if I reduce the fraction, is 1/9. If I need a percent, I divide 1 by 9, and 1 divided by 9 is a repeating 1. So that would be 11.11%. Okay, part E, find the probability that they have no pool given that they have a garage. So I look for the probability that they have no pool and no garage. So here's that probability, 47%. No pool and a garage. And I divide by the total that have a garage, and that's 64. That fraction does not reduce. We change it to a decimal, and then a percent. 47 divided by 64 is 73.44. So as a percent, 73.44%. Finally, the last one, part F. Find the probability that they have no garage given that they have no pool. So I find the probability that they have no garage and no pool. That's 32. These are the ones with no pool and no garage. 32%. or 32 out of 100. And divide by probability that they have no pool. That would be 32 plus the 47. That's 79. Oops, I almost erased the 32. Okay, if we need a decimal for that, we grab a calculator. If we need a percent for that, we grab a calculator. We're going to do 32 divided by 79. I'm going to change that to a percent. I get 0.40506, so 40.51 would be my percentage. 40.51%. And that is the end of our notes.